Fine. So today we are planning to work on lab experiment of Giant 1 and the 4 IoT lab experiments, third year, second sem, and we are planning to work on sixth experiment, that is HTTP based controlling digital actuators. So two actuators we are going to control. Actually the code will be same whether we connect LED or buzzer or relay. So we are planning for two actuators to be controlled, LED and buzzer, from a simple web page. So fine, this is the code. I'm moving to the code already prepared. So this code will be provided. And then see here, this code is for your Wi-Fi connection. So whatever Wi-Fi you are using, mention that Wi-Fi connection over here, username and password. In SSID, mention the network name, and here in password, mention the network password. This is the only one change you may need, or else you can keep the same name of your mobile phone hotspot or your like internet router. So the esp32 will get connected to your router and it will host the web page. Now pins here, two pins I made as output, that is D26 and D27. So this can be used to connect a relay or a buzzer or LED. So yes, so next is in the setup I mentioned them as output and digitally low. That means positive of the actuators will be connected to the supply voltage, that is either 3.3 volts or V in voltages. So this is next about the connections it is mentioned. So if it receives any data from the buttons, so based on that logic are written here to on as well as to off. This is about the coloring at the HTML page. Once you verify the code, just click on this arrow mark for verification. Here it is compiling. If any error is not there, we can upload the code. This entire code will be provided to you in the comment section. Next is uploading, because there is no error. So once I upload, still when we upload also, it will compile. Now the code is uploading. If it is taking time, just press on the boot button on the ESP32 controller, then the code will start uploading. Now it is done as 100%. So one thing we need to take care here is just click on serial monitor here and then reset your controller. In hardware reset I did. So here IP address it will show 192.168, and this is intranet communication. So our laptop should also be connected to the same hotspot what we mentioned here, same hotspot or same internet AR projects I mentioned here. So whatever name you provide to that same hotspot, your laptop should also be connected because it is intranet connection. So go to the any browser and then enter the IP address, you will get the web pages. So in the web page it is mentioned as on. You can see the buzzer is beeping. So when I press here off, buzzer will be off. Now you can observe the voice that buzzer has been off or disabled. This is for experiment 6 to control the two actuators or three number of actuators. So one actuator we are taking it as a buzzer and one actuator as LED and ESP32 board. So using this ESP32 board, we need to develop one HTTP based web server. Using that web server, we have to control these two actuators. So negative of buzzer is connected to the GPIO 26 and negative of LED is connected to the GPIO, that is D27 pin, and positives are connected to, one is connected to V in, that is from the LED, and another is connected to, that is from buzzer, it is connected to 3.3 volts. So anywhere we could have connected, we just needed a supply voltage, that is positive connection. From buzzer we need to connect on 3.3 volts, and positive connection from LED we need to connect on V in, and negatives of LED should be connected to 26 and 27, D26 and D27. So this was about the connection. Next is about the working. So once we click on, so this is how actuator is controlled by using HTTP. It is on, so LED is also on, buzzer is off, so buzzer is also off. Next, if I press on, here also buzzer is on. Now both are on. If I press here off in the web page, in the HTTP server, LED is off. Now if I press here, buzzer is on. This is how the working is. Controlling actuators using HTTP server, hypertext transmit protocol.